Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are a student preparing for competitive exams like JEE, NEET, and other entrance tests, or you simply want to build a strong command over chemistry concepts, then you just have landed in the right classroom. So without ado, let's get started. In today's video, we are going to talk about laws of chemical combination. So there are 4 laws of chemical combination. The first one is law of conservation of mass. Next one is law of definite proportion. Third one, law of multiple proportion. Fourth one, law of reciprocal proportion. And last one, fifth law is law of combining volumes. And this is also known as Gay-Lussac's law of combining volumes. So these are the 5 laws of chemical combination which actually occurs during any kind of reaction in a chemistry. So let's talk about these 5 laws in detail. The first law, that is law of conservation of mass. It actually states that during a chemical reaction, mass of involved species, which are reactants and products, remains same. That means mass before reaction or mass of reactants is equal to mass after reaction or mass of products. So mass of reactant is equal to mass of products. So that is your law of conservation of mass. Let's have a look on this particular law of conservation of mass. Let's know that how this law of conservation of mass is proved. So to prove it, we have to do the experiment, but we can't do it at homes. So there are certain online labs which can be used to understand various concepts or experiments or activities which can be done virtually. So let's talk about that. and I'll show you one very good online lab where you can find out this particular law. Okay, so as you can see, this is uh, an online lab which is actually founded by Ministry of Electronics and Information Technology. So it's a government app, or a lab where we can do a lot of different experiments. Today we are only going to talk about law of conservation of mass and how that can be done. So there are various things it has been given in this uh, particular lab about this particular law of conservation of mass. There is first one, it is theories given, how to proceed, how to, that there might be an animation, videos of different, virtual animation is a virtual video. So how to do it? Okay, so let's see. Okay, so
The law of conservation of mass. We require measuring cylinders, barium chloride solution, sodium sulfate solution, conical flask, cork, 10 ml test tube, and an electronic balance. Measure 5 ml of sodium sulfate solution in a measuring cylinder. Pour it into a conical flask. Measure 5 ml of barium chloride solution in another measuring cylinder. Pour it into a 10 ml test tube. Tie the test tube using a thread and hang the test tube in a conical flask carefully so that the solutions do not mix with each other. Cork the conical flask so that the thread holding the test tube is firmly held in place. Take the conical flask and carefully weigh the flask on an electronic balance with all the contents, ensuring that the solutions do not mix, and note the reading. Take the flask from the balance, tilt it and swirl the flask so that barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask and forms a white colored precipitate of barium sulfate BaSO4 and an aqueous solution of sodium chloride NaCl. Wait for 10 minutes to complete the reaction. The precipitate of barium sulfate settles down to the bottom of the flask. Weigh the contents of the flask again and note down the reading. It will be observed that the total mass of the reactants is equal to the total mass of the products. Hence, the law of conservation of mass is verified.
okay, this is how the animation is given, and along with that there is actual video of performing this particular experiment has also been given over here. So let's do it in the simulator. Okay, so as you can see, there are certain things which have been given in the screen, right? Thread is given, sodium sulfate 5 ml is given, then barium chloride is given. Whatever we have seen in the video, we have to perform. We have to click on this, then see the sodium sulfate is being poured in the conical flask. Then we'll take barium chloride, and barium chloride is added to the test tube over here. Now they are giving you each and every information and next instruction which has to be done. Take this thread and tie it along the test tube, and then you have to proceed to the next step. Now what you have to do, you have to click on the test tube to hang it in the conical flask. So it has been hanged, and then a cork is put on it. Now you will click on it and it will be weighed. Everything, okay, the conical flask, the test tube, and the solutions, which are 5 ml each, sodium um, sulfate and barium chloride, are equal to 150.2137 gram. Depends on what kind of weighing balance you have, right? So this is what you have got before mixing it. Okay, then you take it and then you are going to mix it. Now you can see the clear solution has now turned to white. Okay, keep it as it is, and these white PPTs or precipitates will settle down. Okay, then once again it has to be measured. Okay, they are saying that click on the information icon. Okay, then you have to once again take it and once again weigh. As you can see that the weight earlier without mixing was 150.2137 grams, and now after mixing it is once again the same. So in this particular chemical reaction, what has happened? The weight before mixing and weight before after mixing are same. So hence the law of conservation of mass of chemical reaction is proved. See, it is also flashing on the screen that since the mass of total apparatus remains the same before and after the reaction, the total mass of reactants is equal to total mass of products. Hence, the law of conservation of mass is verified. You can do it a lot of times. You have been given a button to reset it. You will reset it and you will come back to the original format. So this is how it can be done on OLAPs. Alright, this was the law of conservation of mass. Now remember, this law has already been discussed in the previous classes, like it is discussed in the class 9th also. So you will be able to connect with the subject and concept. You must also remember that who gave the law of conservation of mass. It was given by Antoine Lavoisier in 1789. So it was given by Lavoisier. You can also assess yourself in the same OLAB. There are few questions, self-evaluation, which has been given. So there are these questions. Which scientist established the law of conservation of mass? It was Antoine Lavoisier. Which one of the following is the correct order statement for the law of conservation of mass? Mass can neither be created nor be destroyed. Okay. To identify the law of conservation of mass, a student added 10 milliliter of 5% barium chloride solution into 10 milliliter of 5% sodium sulfate solution. Which of the following is the correct observation? We have done it already. It should be a white precipitates formed. Next is a chemical reaction. One molecule of nitrogen reacts with 3 molecules of hydrogen to form ammonia. In the law of conservation of mass, if the law of conservation of mass is correct, what is the number of atoms of nitrogen and hydrogen at the end of reaction? Okay, so there should be N2, 2 nitrogen and 6 hydrogen. Which one of the following combination in the question number 4, let's go back and understand this particular question. It was when nitrogen, one molecule of nitrogen, reacts with 3 molecules of hydrogen, it will give two ammonia molecule, they have to be balanced, means equal number of atoms on the both side of a reaction, means reactants should have equal number of molecules or atoms of same type. Like nitrogen, there is 2, here it is also 2. There are hydrogen, 3 into 2 6, and over here 2 into 3 6. So in reactants and products, number of same type of elements should be same. Okay, that's why there will be how many nitrogen? There are 2 nitrogens, and hydrogens are how many? 6 hydrogens. Which of the following combinations can a student select to prove the law of conservation of mass? There are a lot of things, but remember we have taken all the barium chloride and sodium sulfate as a solution form, not in the solid form. So its answer will be second. While verifying law of conservation of mass, a student added 5 gram of sodium bicarbonate to a test tube containing 14.5 gram of acetic acid. The total mass of the reactant is 19.5 gram, but the mass of products after the reaction is 16.2 gram. The reduction in mass will be, if you talk about this particular reaction, you should remember, let's go back to our note. Now the reaction which we were talking about is the reaction between acetic acid plus sodium bicarbonate. If this reaction takes place, then sodium acetate is formed plus water in liquid form is formed and carbon dioxide in the gaseous state is formed. Okay, sodium acetate is a salt, it is in aqueous form. Bicarbonate is also in aqueous form, and CH3COOH, which is acetic acid, is also in aqueous form. So what happens, why this particular material is decreasing? Because carbon dioxide is actually expelling from the reaction mixture. So what is happening over here? There is elimination of carbon dioxide. Let's take the next question. Which one of the following reactions is not suitable in the laboratory to verify the law of conservation of mass? Okay, this one is done because lead nitrate and potassium iodide actually shows the double displacement reaction. Copper sulfate and barium chloride solution also shows thermal decomposition of ferrous sulfate, mixing of HCl and H. It is not suitable in the laboratory to verify law of conservation of mass. Remember, okay? So when we are talking about thermal decomposition, because in thermal decomposition, what is going to happen? Let's go back to notebook. Okay, when we take ferrous sulfate, FeSO4, and we heat it, what happens? That ferric oxide is formed plus sulfur dioxide gas and sulfur trioxide gas are formed. Okay, this is solid, this is also solid. Now these gases have a tendency to escape from the particular reaction mixture, so hence this is not suitable. So the answer is thermal decomposition of ferrous sulfate. In a chemical reaction, iron reacts with chlorine gas to form ferric chloride. If the law of conservation of mass is correct, what is the number of iron and Cl atoms in the beginning of the reaction? So what we are talking about? We are talking about iron and chlorine gas. Okay, let's go back to notebook once again. So over here, what is done? Iron is taken in solid form and chlorine is taken in the gaseous form. They are reacted with each other, and FeCl3 in solid form, which is ferric chloride, is formed. There are 2 iron, 3 chloride molecules and 2 FeCl3. Now you can see 2 iron on the both sides and 6 chlorine on the both sides are present. So how much iron and chlorine is used? 2 iron, and if chlorine atoms are asked, then 6 chlorine atoms, and if molecules are asked, then 3 chlorine molecules. Let's go back to our question. So the answer is going to be Fe2Cl6. Next, observe the following picture given below. If the reaction obeys law of conservation of mass, what will be the mass of the product? Okay, there is 56 plus 32. What we have to do? We have to add them, and then FeS is formed. That becomes 88 grams. And last one is, to verify law of conservation of mass, barium chloride is not available. Which of the following combinations can a student select to prove the law? So what they can do is sodium sulfate or copper, any kind of sulfate is taken, and along with that, like sodium sulfate, copper sulfate, sodium sulfate and copper sulfate. Okay, what is the difference between these two? See, first one, both are sodium salts, so it cannot be used. Third one, both are once again sodium salts, cannot be used. Second and third one, and fourth one is copper sulfate and sodium sulfate. There is no exchange reaction. But in case of second, copper sulfate and sodium carbonate are used, so they can show this particular reaction. Let's see how much we have got. We are submitting the answers. Okay, first answer is correct, second is correct, third is correct, as you can see, fourth, fifth, sixth, seventh, eighth and ninth, every answer is correct. So you can self-evaluate yourself. There are resources given also, right, from where it has been taken. Okay, and this is how Amrita O Labs helps you in knowing the law of conservation of mass or different laws. So I hope you understand that what is law of conservation of mass, and along with it also understand that how these particular online labs are used for understanding the concept. And that brings us to the end of today's session. I hope you not only understand the concepts but also gained confidence in solving competition level questions. So, thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.